So I welcome you to look at some questions from topic called periodic classification of elements. Let us look at the first question. Which of these electronic configurations represents smallest atomic radius? Smallest atomic radius is possessed by halogen atom, that is 17th group element in a given period. 17th group elements have 7 electrons in the outer level, Ns to Np5. Similarly, six electrons are there in 16th group element, say Ns2 Np4. If you have Ns2 Np6, as you know, it is 18th group or noble gases. As a rule, I am telling you, smallest atom in any period is represented by a valence electron configuration Ns2 Np5. Check which has that. First option is not, second option is not, third option is yes. Fourth option is not. Now the same question can be asked other way around. Which electronic configuration represents the biggest atom? In any given period, generally the biggest atom is belonging to first group or alkali metals. First group elements have one electron in the outer shell, Ns1. We see as many possible levels as you should see with Ns1. So it is having Ns1, 3s1, 3 levels. Okay. The biggest atom, if they ask, your option is A. Smallest atom, if they ask, option is C. If they ask which of the following is representing 14th group element, see which has 4 electrons in Ns2 Np2. Ns2, the N is 4th level and N is 4th level, 4s2 4p2. 14th group. If they ask which of the following configuration represents 16th group element, 16th group element means 6 electrons, Ns2 Np4. Which represents 17th group element that has 7 electrons, Ns2 Np5, which represents first group element, Ns1, like that. If any element has incompletely filled d orbitals, then you should say it belongs to D block. Okay. Order of decreasing radii indicated. Generally, the radii will decrease across a period. Radii can also decrease if it is a positive ion. More positive ion, the smaller the size. Always remember, positive people are humble and they are simple, they look small. Negative people are proud, they look big. More negative charge, more bigger the size. Now they are asking order of decreasing radii. Decreasing radii means in periodic table you should go from left to right, not top to bottom. Oxygen, sulfur, selenium, tellurium indicate down 16th group. So it is not decreasing order, it is increasing order. Lithium, beryllium, boron, we are going from left to right, but aluminum has come down. So the size of aluminum is bigger, it is not. Carbon, nitrogen, oxygen, fluorine, excellent. You are going from left to right, second period. Size is decreasing. Fluorine, chlorine, bromine, iodine is not because you are going down that way. Where second atom is bigger than first, same logic. Down a group, the atomic radii increase. Lithium, hydrogen is not. Argon, chlorine is not. Bromine, chlorine is not. Nitrogen, phosphorus, yes. Which ion is biggest? Already we said the more positive charge on the ion, the smaller the size. And down a group, the sizes increase. Rubidium is in the bottom of first group. So it is the biggest ion. If they ask smallest ion, that is aluminum. Highest ionization energy 2. First ionization energy is highest for 0 group elements. Second ionization energy is highest for first group elements. Third ionization energy is highest for second group element. Okay. The top the position, the higher the ionization energy. So IE2 is highest for first group element. Check which is first group element. It is second group element. It is second group element. It is first group element. It is 16th group element. IE2 is highest for second group element. Generally, IE2 is to be considered for unipositive ion. It is a better way of asking. Okay. Correct order of electron gain enthalpy for 16th group elements. Generally, electron gain enthalpy, absolute value they are asking, modulus. If you put 2 lines, it means you are not taking the sign. You are looking at only the value. Okay. Absolute value of electron gain enthalpy for 16th group element has this order. Sulfur is greater than, selenium is greater than, tellurium is greater than oxygen. Why oxygen is having lowest electron gain enthalpy means the atomic size of oxygen is so low, if you add an extra electron, added electron is repelled by existing electrons. So energy released in this case is less. Notice electron gain enthalpy is usually after adding electron, energy is released. Electron gain enthalpy is usually negative. For second group elements like beryllium, magnesium, calcium, the electron gain enthalpy is positive because they don't want electron. Positive means you have to force the electron to go and energy is to be consumed. Similarly, for 15th group element nitrogen, electron gain enthalpy is positive because it also dislikes to gain the electron. Generally, atoms which have fully filled orbitals or half filled orbitals are stable and they are not interested to take extra electron because adding electron will destabilize the configuration. Anyway, correct order of electron gain enthalpy for chlorine, bromine, iodine. Again, Cl is greater than, fluorine is greater than, bromine is greater than iodine. Electron gain enthalpy means actually when you add the electron in the valence shell, the energy released is highest for Cl. But the ability of an atom to attract electron pair in a molecule, the love towards electron pair in a molecule is measured in terms of electronegativities. And electronegativity was originally defined by Linus Pauling. In Linus Pauling, the scale is relative. If you take hydrogen as 2.1, then relative to hydrogen, the ability to attract electrons in a molecule is highest for fluorine, it is 4. Chlorine is less, that is 3. Bromine is still less, iodine is least. Always in the entire periodic table, element with highest electronegativity is fluorine. The electronegativity was also defined differently by another scientist called Mullikan. As you know, Mullikan electronegativity is average of electron gain enthalpy I1 and ionization energy. Electron gain enthalpy and ionization energy average is taken as Mullikan electronegativity, and Mullikan electronegativity has units of energy. Pauling electronegativity has no units. Mullikan electronegativity is 2.8 times greater than the Pauling electronegativity. You should know that. Mullikan electronegativity has energy units, but Pauling electronegativity has no units. The first group elements have very less electronegativity. It means the alkali metals have very less electronegativity. In fact, they have electropositivity, means they have a tendency to lose electrons. You should know, a fellow who is losing electrons is making others to gain electrons. A fellow who is losing electron is called a reducing agent. So, first group elements are good reducing agents. 17th group halogens, they have a tendency to gain electrons. They have high electronegativities. Fellow who is gaining electrons is making other to lose electron. It is called as oxidizing agent. 17th group elements are good oxidizing agents. First group elements are good reducing agents. With that note, we close this session.